So I originally found your work whenever I was researching like ways to refine lunar regolith,
Mhm.
and I found like one of the hardest problems is how to reduce all of the
Mhm.
oxides. And I found your paper on calciothermic reduction, and then from
Mhm.
there I just started reading other work that you had done, your fluorine
Mhm.
process, and and so that was really cool. And I made a video on refining regolith. And then later I was making a video on how to make solar cells. And of course I ran into your work again. And then later I was looking into making lunar glass, and there your name
Mhm.
was again. And so you're kind of everywhere. And so we kind of call you like one of the founding fathers of lunar ISRU. And so it's
Wow.
an incredible honor to interview
Mhm.
you. Yeah. And I know it's been a while since you've really done a lot of that work, but a lot of your work is very near and dear to our hearts, and
Mhm.
it's like stuff that's currently being re-looked into today. But but I guess my question for you is, how did this journey kind of start for you? How did you get into NASA and ISRU?
Well, actually, I started out as a postdoc at NASA working on solar cell development. So my entry into the field was through power systems and solar cells. But I should also say I've been kind of a space fanatic since way before then. I was the generation that was just coming into uh, college, etc., when Gene O'Neill came out with his uh, great book on L5 colonies, Lagrange point colonies, and was sort of very interested uh, in that. And of course, a big portion of O'Neill's argument was saying that if we're going to do this, we have to use the resources already in space. So one of O'Neill's ideas was he did ask the question, what's the economic base of a space colony? And that is the most critical question. I think we have to say we still haven't totally answered that. It needs to be answered. But he pulled away Peter Glazer's concept and said, well, the economic basis is to make power systems that could beam power to the Earth. But just as important, maybe more important, I think, is, well, you need power everywhere in space. So he got me thinking about the question, how would you actually realistically make solar cells on the moon? So I was sort of combining my knowledge of how to make solar cells with the question, what's available on the moon and how do we use it?
Yeah, so there's several branches of that I want to get into.
Mhm.
I guess, what do you think ultimately is the utility of the moon?
Well, to start with, it really is the closest destination that has resources that we can use. So if we're going to start making settlements in space, it is the place to start because it's the nearby place, and we can learn how to utilize the things we can find in space. Of course, asteroids are also something we should think about, but they're thousands of times further away. Uh, there's a strong argument among some people in the space community that says, well, ultimately we'll get our resources from asteroids. In the near term, probably near Earth asteroids, in a farther term, main belt asteroids, and maybe beyond that into the ice belt. But to start with, they're just too far away. We have to start with what we have nearby, and that's the moon. Of course, recently we've been pretty fortunate in that after many decades of speculation, uh, we're pretty sure that there is large amounts of water ice at the polar regions of the moon. So a lot of the thinking recently has been, well, let's stop exploring the near equatorial regions. That was mostly the focus of Apollo, and well, let's go down to the near polar regions where we have not only all of the regolith and all of the things that you might be able to make with the various components of regolith, but we also have some of the volatile compounds, most notably water, of course, but several other volatile compounds seem to be there. So the story's beginning to come together. But again, in the long term, for settlement, the question is, what is the economic base going to be? What are we
Yeah.
getting or what are we making that's going to pay for the endeavor?
Yeah, and O'Neill argued heavily for
Mhm,
space-based power, and
mhm,
I know you have a long history of
mhm,
looking into power beaming, and you've done recent research with that. Um, and I had a whole list. I had a whole list of questions regarding like refining and stuff. But you're jumping right ahead,
mhm.
so I'm all for
Well,
it though. I
well,
guess I'm
actually, I was
curious.
jumping behind sort of how I got started.
Yeah, yeah, no, it makes
Mhm,
sense. So you were interested in the power beaming and sort of
mhm,
trying to see where you could help fulfill O'Neill's kind of vision. And I read The High Frontier, and I
mhm,
feel like a lot in that book still stands today. Um,
mhm.
and I could tell he was trying to give a hopeful vision during troubling times during the 70s and stuff. And I see a lot of parallels with what he was
Yes.
pushing for then and today. Maybe it's just the
Mhm,
continuous state. Maybe it never really changes. But I definitely think, I guess I was curious. So a lot of the biggest pushback that I hear when it comes to space-based power beaming is that, well, the difference between like a Neil's day and
mhm,
today is like today solar panels are so cheap. And I'm curious if you
mhm.
still think there's a strong case to be made for space to Earth power beaming. And then that kind of answers the question of what's the utility of the moon. Because if the answer is
Mhm.
yes, then it's like, well, the moon is its mass already in orbit, right? It's the feedstock from which we can make those. So yeah, but I guess I'm wondering, do you still think there's a strong case for space power beaming to Earth?
Yeah, I should emphasize, of course, that that's not the only possible utilization of the moon. It was just the one that sort of kicked me off. And once we can start manufacturing things on the moon, there's a lot we can do with it. And probably a nearer term case would be if we are going forward and settling space, we are going to need power. So the customers, very likely the first customers for solar cells made on the moon, would not necessarily be customers on Earth, but would be customers that are moving out into the solar system that would want power systems that are made and we don't have to lift up from the from the surface of the Earth. The case for beaming power from space to Earth is so complicated and so technology dependent that it's hard almost to answer that question. Uh, it's a question of can it beat out other technologies? Other technologies would be, for example, what if we could use superconductor cables to move power over distances of tens of thousands of kilometers? So, well, that's a crazy idea. It's really hard to make systems that transmit power tens of thousands of kilometers. But if we could, then it obviates a lot of the same problems that space-based power uh, deals with. It allows you to make power, for example, in Africa and use it in England, or to make power in, who knows, in Mexico, for example, and send it to Alaska. So it's very technology dependent. Can we get uh, space based power to the point where it's a clear winner over other technologies? And the answer is maybe. Uh, it would probably be a development system that we just keep incrementally improving. So, well, let's see.
Yeah, I think the best argument I've heard for it is that there's ultimately, if you think further into the future, it is like the
Mm-hmm,
ultimate scalable technology. Like there, even if we covered the entire planet
mm-hmm,
in solar cells, um, the only contender that kind of could give it a run for its money could be fusion. But then fusion has its own problems.
mm-hmm.
Whereas space-based power is just a matter of scale. Like we've had this technology for decades now. Um, so I'm all for both, but I question. So I do question if you have any thoughts regarding microwaves versus lasers for beaming. If there's inherent advantages
That
or disadvantages.
that would be a long discussion that I think
All
probably we
right,
should push off to another
makes
discussion.
sense.
That really is a long discussion. The quick
Right.
answer is different technologies have different niches.
Okay. I wasn't trying to get too lost in the weeds regarding this subject. So you mentioned the first customers for space-based power will be customers in space, and I was curious what you thought about instead of sending all the power from space to Earth industry, the idea of like moving Earth industry to space, and so you're using the energy where you're creating it. and sort of offloading the
Mhm.
power burden from Earth. It's kind of approaching the problem from the other direction.
Yeah, that's been one of the arguments that people have been made. Once we have resources in space, once we can tap the resources of the moon and beyond the moon, why not move manufacturing off of Earth? Why don't you just manufacture everything in space? Why dirty up the planet that we love when here's a planet where we really can't pollute it because there it isn't there's nobody there. I love that idea. I think to some extent people are arguing it backwards. What will happen is when we start manufacturing in space, we discover that everything that we call a waste product on Earth, we would call a resource in space. Um, all of the things that are pollutants, we'd say, oh my gosh, look at how valuable that is. We can use it. So the space industry is going to teach us how to recycle all of the products and the byproducts of manufacturing. We're not going to just dig stuff up and throw out most of it and say, well, okay, it doesn't matter if we use 2 tons of cryolite for every ton of aluminum we make because, oh, we'll just dig up some more. We'll uh, pretty much have to learn technologies that reuse everything. We can't afford to throw away stuff and say, oh, we've used it once and thrown it away. So I think the real benefit of space manufacturing is it will teach us to manufacture without polluting.
Why do you think it takes space to do that? Do you think, like, why couldn't we do that on Earth? Do you think just, I guess, to kind of answer my own question, is like, I feel like the value is when we start sort of
Mm-hmm.
new, like in a new
Mm-hmm.
space, it's
Yeah.
easier to, we have all the, yeah, you don't have the baggage, the historical baggage.
Mm-hmm.
That would be
Yeah, that's a big part of it. When we start anew in space, we're not forced to do the techniques that we've always used on Earth. In fact, we can't. If we make steel on Earth, we dig up a couple of tons of coal and use that to reduce the iron oxide. And of course, wouldn't do that in space. We have to come up with a non polluting technology. We can't burn fossil fuels for energy in space. We have to do something that gives us the technology to work without burning stuff we dig up out of the ground.
right. And lots of people talk about the advantages of the, nearly limitless solar energy in space. It's just how much surface area you can,
Mm-hmm.
collect. But I think a very overlooked is the advantages of vacuum in space, especially when it comes to
That's
things like
also true.
refining,
Yeah. Yeah.
and that could be a huge boon to our industry. Just that alone. You mentioned steel, and of course, I mentioned like I discovered your work when I was looking into refining, and I know you did the calciothermic reduction. I actually
Mhm.
recently did some calciothermic reduction experiments of some lunar regolith, and the results were very interesting. Um,
So,
yeah, it's very cool. And then your fluorine process, and
mhm.
um, and I was curious, do you have any thoughts? Are you familiar with like pyrolysis, the concept behind pyrolysis and using vacuum and just like thermal energy to reduce the oxides?
Yeah, people have proposed vacuum pyrolysis. I'm a little bit skeptical of it. When you start vaporizing things, what you discover is that the vapor condenses everywhere. You're sort of getting junk over everything. The other problem with vacuum pyrolysis techniques is that they're very, very high temperature, and high temperatures are just hard to deal with. You always have materials problems. It's easy to get a moderate temperature solar furnace. It's okay if you start pushing it up into high temperature, but when you start really getting into the temperatures where you can start dissociating these complex oxides and silicates, wow, it's hard to produce that. It's very energy inefficient. So I've looked into it, but it's not my favorite technique. But I won't. If somebody can develop it, I'll say, hey, wow, great, do it. See what you can learn.
Yeah, I think the idea behind that is that like with the levels of vacuum that you get on the moon,
Mhm.
you can do
Yeah.
it at like you could break like silicon dioxide or alumina at like 1500 degrees Celsius. So that's like around where we melt steel today. But like you said, the vapor just kind of gets everywhere. And I think that the linchpin of that technology, like the hard thing to figure out is how to do differential distillation, how to kind of
Hmm.
separate,
Yeah.
molecular distillation. And I would really like to see that done more, but it's kind of hard to test that in vacuum and then
Hmm.
try how you don't dirty your vacuum system
Yeah. Yeah.
and and then also
Uh,
like regarding that, it's if hopefully you could get high purity, that would be the dream. But that's also I think that's why you made the
mhm.
fluorine process, um, because your goal, like in order to make solar cells, you have
Mhm.
to refine regolith,
Yeah.
right? And then the
Right.
fluorine process, we would probably have to import fluorine from Earth, probably the nickel alloys of the
Right.
system from Earth, but you could have that 99.9999, however many nines it is, that you need in silicon for solar cells. So I guess I was curious if you've had any more thoughts or done any more work with the fluorine process since that paper you
No,
published.
actually, I sort of moved on from that to think about calcium instead, mostly because a lot of the calcium process has been kind of thought out by people working on refining titanium. So it's a little bit further down the learning curve. I think there's still a lot to be said for fluorine, but there's also a lot to be said for something that people have been trying to industrialize for a different metal. And actually, titanium would be very useful if we can make that on the moon as well. Of course, ultimately, we want to distill everything out of the regolith. I think all of the components are going to be useful.
Yeah, I think aluminum is like the holy grail. I think if you can get that, because it's one of the
Hmm.
hardest to get. That's how you can make electrodes. That's how you can make solar cells. It's how you
Hmm.
can make a mass driver. and
Hmm.
but I did some calciothermic reduction. We haven't had it like fully. We did like some hydrolysis on it, but we haven't done like a full quantitative analysis.
Hmm.
That's coming, but we did get like slag separation, even though it cooled so quickly. And I was just thinking, like, we might be overthinking this with all of these different
Hmm.
methods of trying to figure out purity. But if we're in like somewhat low gravity and in the vacuum, it's gonna like self anneal, right? It's gonna take so long to slow down. What if all these like reduced oxides just separate on their own, and so you're
Hmm.
just gonna have like
Yeah.
oil layers of, and it's like that would just be so easy. I guess the hard part would be
Sure.
returning the calcium from the calcium oxide.
Hmm. Yeah.
But you have high electrolysis and different
Yeah.
approaches to
That
do that.
that is the trick. You've got to you've got to recycle at least all the calcium that you used, and probably you want to make some more as well
Yeah.
because it is in itself useful. That's
Do you do you have any thoughts on like mass drivers or just
Yeah,
in
mass
general?
drivers is one thing that I haven't worked on. I know a couple of the people that have worked on mass driver type experiments, but I think I'll have to say no. It's out of my expertise.
Yeah, that's I feel like mass drivers need a lot more attention, and I also think like
Mhm.
in a lot of ways they benefit from like the equatorial regions of the moon. And if like you had a mission that was more about establishing a mass driver rather than
Mhm.
boots on the ground, it would change a lot of the strategy and how strategy kind of dictates tactics. And it would be like, okay, actually the equators are really good for this. Like in order to make a mass driver, you have to power it, and you could send up
Mhm.
nuclear reactors, but you
Yep.
could also make solar cells from the regolith. And if you can refine regolith, you could do both, and so the key to
Mhm.
everything is, I think, refining.
Yep. And
So
solar
yeah,
cells, of course, has been kind of my passion, but there's a lot more, of course, that we want to be able to build and make. We want all sorts of structural materials. And as you say, aluminum is going to be a very high value material, not merely for its structural, but also because it's a decent conductor. So we can make wires from aluminum. Copper, on the other hand, is pretty rare on the moon. It's not it's not completely absent from the moon, but it is certainly not something that we're going to get very much of out of a refining process. Calcium, on the other hand, is also a good material for wires. So
and yeah, and we wouldn't have like the problems with reactivity as much, like
mhm.
with
Yes,
that, the atmosphere and stuff like that.
you don't have to worry about the calcium wires going up in flames. Yes,
Your original papers looked and suggested amorphous versus like crystalline. And I thought that was just genius because the advantages are like, yeah, they're 10% less efficient than like monocrystalline or
Hmm.
polycrystalline, but it's 100 times less material. And you
Yeah.
could do like thermal annealing if you have the hydrogen. You can, get the,
Hmm.
if you can, saturate it with the hydrogen. Do you still feel like that's the case, that amorphous is still the best bet, or have there been some developments
Uh,
since then that make you?
Actually, I've somewhat changed my mind on that. If you're using silicon, there really is a lot to be said for amorphous. You do need hydrogen, but it looks like there's enough hydrogen on the moon that you can make hydrogenated amorphous silicon. As you point out, the efficiencies are a little bit lower, but you don't have to grow the single crystal. And in thin films, the hydrogenated amorphous silicon has beat out the microcrystalline silicon. Nobody's really made good microcrystalline thin film solar cells with silicon. It's a pity. That would be a nice solution. But recently, the solar industry has turned to looking at a new material called perovskites. Uh, Now, perovskite is just a mineral structure. It's a crystal structure. It's not actually the material. But the particular perovskites that they're using uh, have phenomenally high absorption coefficients, meaning that they absorb a lot of light in a very, very thin layer, which means that you really don't need very much material. Now, the bad news is we may not be able to make the perovskites easily from lunar material. But the good news is that their thickness that you need is so little that it just isn't going to be a problem to bring the perovskite based material uh, to the moon. I mean, you need a handful, literally a handful of material can make many, many square meters of solar cell. So the thinking would be that you make all the heavy stuff from materials made on the moon. You make the glass, and glass is a big deal. You make the aluminum frame. If you need structural steel, make the structural steel. You make the substrates for deposition. All of the heavy stuff is on the moon, and the perovskite layer is literally thinner than a coat of paint. And well, okay, you bring the paint can from the Earth. There's a lot of interest in perovskites on the Earth, and the best perovskite cells are pushing the efficiency of silicon cells. And actually, a lot of people are saying, well, why don't we do both? Make one layer of perovskites and a layer of silicon. The difficulty of perovskites so far, part of it has been degradation. Can you make them last? And for terrestrial solar cells, you want them to last for 30 years. You buy a panel on Earth and it comes with a 30-year warranty. The worst enemy of perovskite solar cells on Earth is humidity. They degrade when exposed to too much humidity. But hey, no problem on the moon. There is no humidity. Uh, so it's very likely that that might be the absolute killer solution on the moon is to bring the perovskite layer, the actual solar conversion layer, and everything else, the wires, the glass, the substrate, the structure, everything else you can make on the moon. So that would currently be my thinking.
Yeah, I didn't realize that they could be. We call it um, like magnification or amplification of
Mm-hmm.
imports, where you have to probably there's potassium on the moon, obviously, but it's in like parts per million. I
Yes.
forget what it is. Gonna
Yeah,
be hard to get.
the creep
Right.
material indeed.
Yeah.
Yeah.
So you already have to bring
Mm-hmm.
some of your dopants, but it's okay because it's like, a kilogram can make like, 100,000 square kilometers or whatever it is. It's
Mm-hmm.
such a small
Yeah.
amount because
Yeah.
it's an atomic amount. And I didn't realize perovskites had that similar effect. That's actually really exciting because, yeah, if you can, like you said, bring, a few grams can turn into, a square kilometer or whatever.
Well,
That's awesome.
probably not a square kilometer, but many, many square meters.
Mm.
Yes.
Yeah, there's somewhere like I don't know what the line is, and I guess it would depend on cost, but
Mm-hmm.
there's some trade-off where it's like it just becomes worth it to just import versus,
Mm-hmm.
you
Yeah.
know, not.
Yeah.
And then, like you said, a combination of like sourcing your glass and all the heavy stuff on the moon.
Mm-hmm.
That makes sense. That's cool. And I guess if not, then the fallback would be probably amorphous.
Well,
So,
whatever
yeah.
people can make, maybe people will make those breakthroughs and can make a high efficiency cell from thin film crystalline silicon. So
Hmm.
far, the people who have tried it have not gotten good results, but well, people keep coming up with new ideas, so maybe they'll find the solution.
Yeah, well, hopefully. So, do you have any unusual ideas for the moon or space that people tend not to talk about?
Oh, I have a ton of old ideas that are in sort of my idea files, and say, whoa, somebody ought to work on this, but I'm too busy right now.
Please share. Maybe we can make a list and.
Well, one of the odd ideas that I wrote up once for the Journal of the British Interplanetary Society was the idea of a sling launcher. Now, actually, people are working on a similar idea for Earth, where it's a crazy idea. The idea of a spin launcher where you spin around and then you eventually let it go and uh, just push it off through the atmosphere based on its momentum. That doesn't seem like a reasonable idea. I mean, I love the guys doing it. I wish them success, but I'm thinking, wow, pushing through an atmosphere uh, essentially with a sling, man, that's going to be a hard sell. But on the moon, that makes a lot of sense. So my calculation was that you could basically do a tether, a thin rope of a high strength material. Kevlar would do. Ultimately, of course, people talk about these graphene nanotubes, Bucky tubes, and then you can just sort of slowly spin it up and eventually spin it up to speeds where you can exceed the uh, escape velocity of the moon. And I think, wow, that would be straightforward. Uh, but I've just been too busy with other projects to work on that one. I really need a mechanical engineer for for a collaborator on that one. If you know any, send them my way.
Yeah, you need so yeah, in general, like the moon, the free vacuum means it's like the capital costs are orders of magnitude
Mm-hmm.
smaller, and also the target orbital velocity
Mm-hmm.
is so much smaller that mass drivers just make a ton of sense for the moon, and then for Earth they would be nice, but it's like
Mm-hmm.
it becomes a much more of a mega project. I get, do you have any thoughts regarding like the trade offs between, I guess, spinning versus just a linear, like a coil gun or a rail gun versus this, the kind of the spin launcher on the moon. It just it
Yeah.
takes less space in general, I guess.
Yeah, in some ways it would take less space, although very likely space is not going to be the biggest deal on the moon. If we have to make a mass driver that's 10, 15 kilometers long, well, it's not a big deal. The real question on mass drivers is can we scale them up to the speeds needed and the masses needed? And that's an open question. There's certainly people working on that sort of problem. And then people have proposed other things from time to time, but I'm I'm good with whatever people can make that can work. Just launching off the moon would be nice if we can do that without using fuel.
Yeah, I was talking with a friend about the spin thing, and I said I
Mm-hmm.
think that the disadvantage is that you have to wait for it to kind of spin back down before you reload it, versus like a coil gun, you can just shove
Mm-hmm.
constant stuff in. And he responded, well, not necessarily, because if you have a long spinning one in the center, it's going to be going really slow, and towards
Mm-hmm.
the end, it's going to be going extremely fast. So you could just
you
sit
could
there and load it
you
on.
could feed it from the center. Yeah, in
Exactly. Yeah.
general, mass drivers and coil guns, the limiting factor is how fast you can charge up the capacitors. So you're probably not going to be shooting off one payload every minute or two. You're going to be spending most of your time charging it up, and then then one brief 30-second discharge, and then back to charging it up.
Yeah, I think that's like a big advantage of the a spinning launch system. If you can feed it in the center, is it can
Mhm.
just be kind of fed constantly,
Mhm.
just a giant, motor more or less. And then, yeah, were there any other crazy ideas you have?
Oh, I could probably go through files and find my share
Hmm.
of crazy ideas. There's ideas are one thing. Turning them into reality is the hard part.
Right. And some of these questions are coming from like my audience and stuff.
Mhm.
And someone asked, are there any common mistakes or misconceptions you have seen among like space knowledgeable people, like in the NASA expert pool or just in general, which you feel are sort of holding us back in some ways?
Wow, now that's an interesting question. There's certainly a lot of misconceptions in space, but I'm not sure if, because once you get to the people who are actually doing the engineering, they mostly know what the misconceptions are. Uh, I think the one thing that I'd like people to think about a little bit more, uh, well, not really a misconception, but I really would like to see more work done on some of the nuclear systems for the moon. Uh, both nuclear power systems, but also nuclear rockets. We worked hard on nuclear rockets in the late 1960s. And then when the program to go to Mars got abandoned, the thought was, well, we don't have a target for the nuclear rockets. Why are we making them? So I guess that's not really a misconception, but it's a line of research that I think we really need to get back into to expand both from the moon and even from Earth to moon. That would be nice to have, uh, but really useful when we're going to go out from the moon and go further out into the solar system.
There's a lot of different like designs. Are there
Mhm.
any nuclear propulsion designs that are sort of near and dear to your heart, or
I would
just
like
whatever works?
anything that works. Right now, of course, the two major contenders are nuclear thermal propulsion, which is high thrust and pretty good specific impulse, but requires hydrogen as a fuel, and nuclear electric propulsion, which is low thrust. So it's slower, but is tremendously fuel efficient. So my thinking is, well, let's do them both. We need them both. But
Yeah, I always liked the. I think it was the Orion, the craziest one, which is where they drop a bomb out the back and push a. I've always questioned why can't we do that instead of a big spring, like a mechanical spring? Why not use like electromagnetic fields, like as the spring? So it, I don't
Mhm.
know, maybe you could tune them in and then tune them out with the explosion. So it'd be like squeezing, a bar of soap in some ways. Um, Anyways, that's just my crazy thinking.
Yeah, I think in the Orion pulse nuclear propulsion, the mechanism of shooting the bombs out behind the spacecraft is the least difficult problem in the whole system.
Right.
It's
Yeah.
riding a riding a nuclear explosion at close distance. Now that would be exciting.
hmm Yep. For sure. And then I've always thought, in general, like most of our biggest achievements, like throughout history, have come from infrastructural developments and stuff, and
Hmm.
and energy. Like if you have energy, you could do anything. So that kind of gets us back to the
Right.
energy and space question. Um, so I guess going back to I think the first thing you said, which is that like the economic side
Hmm.
of things. What economic incentives do you foresee very early on? I know O'Neill said space-based solar power and also living in space habitats. I think people would like to live in habitats, but I don't think that sort of solves the chicken and the
Hmm.
egg problem.
Hmm.
I think that comes after. For me, I see oxygen exported from the Earth for our low Earth orbit infrastructure
Hmm.
as a potential first market, and then also possibly tourism. Although that
Hmm.
one is probably more limited, and it comes with its own human spaceflight drawbacks. What are your thoughts on this?
Well, actually, another idea that I think could be looked at in more scrupulous detail on the moon would be mining for precious metals. A lot of people have talked about, oh, we should go to nickel iron asteroids and try to harvest platinum group metals. And that's a tricky idea, but might not be a bad idea. The problem is that while platinum group metals are enhanced in the asteroids compared to the Earth, that's not quite the same as saying we have ore deposits. You still have deposits that are now many parts per million instead of a fraction of a part per million. But that's still not entirely a dumb idea. But there's plenty of nickel iron asteroid fragments on the moon. If you just rake through lunar regolith with a magnet, you'll find pieces of nickel iron because it's been sitting out there for 4 billion years getting bombarded and some portion of the bombardment has been with nickel iron. So what I would look into if I were trying to be an entrepreneur to come up with $1 trillion idea for how to use the moon, I would look into separating out some of these nickel iron fragments and using a probably a carbonyl processing to harvest out the platinum, palladium, iridium, rhodium group metals. So that would be my thought for an economic basis for the moon. Shoot it
Oh,
down if you
interesting.
want, but it's something that we could use on Earth.
Well, yeah, there's a lot to say. I was going to mention earlier when you mentioned people say we should go to like Earth asteroids, but they're so far
Mm-hmm.
away. It's like people forget the moon is covered in asteroids. So that's
Yeah.
there and it's easier to get to. It's
Mm-hmm.
like also the thing with like even near Earth asteroids is the time involved and just getting to them due to like
Mm-hmm.
orbital dynamics and stuff. Which if you've ever played, like Kerbal Space players will know, like getting to a near Earth asteroid is not that. It's near Earth, but it's harder to get to. Anyways, um, but you mentioned carbonyl processing for those
Yeah.
specifically.
Yeah.
Why
Yeah.
that versus like calciothermic or
Well, in the nickel iron asteroids, they're already reduced. They're already in the metallic form. So you're not trying to get rid of the oxygen. What you need to do is separate the platinum group metals from the iron and the nickel. So the question is, what chemical process will pick up iron and nickel and move it away and leave the platinum, palladium, iridium behind? One of the interesting things is if you expose uh, nickel, iron to high temperature carbon monoxide, it will form a complex called a carbonyl, which is easily vaporized. So, in principle, you could transport away the nickel and the iron, leaving behind the elements that don't quite so easily form carbonyl. So, it's a question of temperature. What's your processing temperature? And the interesting byproduct of it, by the way, is that you can distill out absolutely pure iron and absolutely pure nickel because they have different carbonyl vapor points. It's easy to distill them, and then uh, you can pyrolyze it. It's a reversible reaction. You can reverse it and pull the carbon monoxide off again. Of course, you do need carbon for that, but there's some fraction of carbon in the lunar regolith. You can find it. It's not the major component, but it's not a trace component, and especially if you harvest, thousands of tons of regolith for other purposes, you can just drive off carbon dioxide and carbon monoxide that's been adsorbed into the surface. So it's
right?
not an impossible process. It would take a lot of chemical engineering.
Yeah, that was another question I had, which was but I think you already answered it. But we could try kind of change it a little bit. I was gonna ask if you what would you send to the moon if you had $1 billion, kind of a king for a day. But I guess I could do if you were like put in charge of NASA or the but I don't want to get you in trouble because I used to work for NASA. So so how about
Yeah.
if if you had $1 billion, what would you send to the moon to kind of kickstart this? Would it be that carbonyl reactor?
Well, there's a lot that we need to know about the moon, and there's a lot of technology we need to demonstrate on the moon. Uh, the first thing is we still haven't actually touched the lunar ice in the polar craters. We don't really know the physical form of that ice. So I'm just absolutely fanatic about saying get missions like Viper, get rovers into those craters. We really need, before we can do anything, we need to see what that ice is. What's the form? It could be Portland cement. We're sort of thinking, oh, yeah, well, we know how to cut blocks of ice, but we don't know what lunar ice looks like. Uh,
Yeah, do you think it's as easy as just steaming it out?
it's probably, but we don't know that for sure. Uh, Keep in mind, Portland cement is also a high water content material, and but we don't say, oh, we need some water. Let's take a chunk of cement and then boil the water off. Well, that would be hard. So, in terms, and the science value is tremendous. We need to learn. There's layers and layers of ice. What can we learn from them? I don't know. So part of what I would do would be definitely looking, just getting a hands-on experience with the lunar polar ice. The other thing that I would really push is getting a demonstration nuclear reactor working on the moon. That long, long nighttime and the craters with no sunlight, you'd really like to get a nuclear power system there. So uh, but to be fair, this is things that NASA's already interested in. So I'm really just saying, push these things up to the highest priority. But other than that, there's a lot of useful things we could do on the moon.
Yeah, I agree. And I talk a lot about solar cells, and we talked a lot about solar cells here. And I think solar
Yep.
cells are awesome for like once you want to scale to exporting thousands
Yeah.
of tons of mass to mass drivers and all the associated vehicles that will need to come with that. But in the beginning, like new reactors are awesome and they make a lot of sense. The hard part is just having to import them, every single
Yeah.
time you want to increase your capacity for
Yeah.
something.
Absolutely. Absolutely. I love solar cells. I've spent much of my life working on solar cells. They're a great solution to many problems, but every technology has its niche, and solar cells are absolutely unbeatable in any application where you have sunlight. But there's applications in space where you don't have sunlight. So,
What do you think about sort of in that same vein? The it's like it's all or nothing, but versus like humans versus having robots kind of do most of the work, and then on top of that, having the robots only work during the day. Like if 99% of your economy is machine, and then it only needs to run when there's sunlight, I think it solves a lot of problems. What do you think about humans versus robots? Do you think we should really focus on boots on the ground? Do you think they're still necessary in the loop, or do you think teleoperation um, can get us most of the way there?
I think humans and robots could and should work together. It's not an either or thing. We would want humans and robots there doing work. Having robots exploring space is great, but it's like having your friend go on vacation and send you postcards. It's not quite the same as being there. And humans are very, very versatile. The main problem with humans is that we're fragile. But given that you can make habitats and you can make a place for humans to stay on the moon, I think the humans and robots working together are the absolutely the best solution.
Yeah. Do you think we would need like a small amount of humans to, I guess, at first, to just get the ball rolling? I guess I'm curious, like the proportion of
Mhm.
human. You foresee humans and robots working together, but do you think we could have like just a very, very small amount of humans on standby for like repairs and stuff, and a very large amount of robots, or do you think we're probably going to need more humans in the loop than we probably estimate nowadays?
It's nice. It's nice to have humans in the loop. Humans are very good at decision making in terms of things like what to do and how and when, and what to do if there's a problem and what constitutes a problem. So I think the humans are not just there to every now and then troubleshoot, but they're a specific and important part of the solution in working together. And everybody thinks, oh, sooner or later we'll make robots that are self-repairing. But well, I don't know. Right now, we're going to need need humans to sort of do the tweaking and running the operations.
Yeah, I kind of foresee like humans in a machine shop if they have like access to CNC and all the equipment that they would
Hmm.
need, and then they have an ability to refine that metal from mostly metal, not all metal, but from
Hmm.
regolith. That's like such a powerful thing,
Yeah,
that if you're thinking
yeah,
about like a seed to send to kickstart everything, it would be like humans with a and a mill
yeah.
and the ability to
Right,
refine.
right. You
Um,
want both.
right. So what do you think is an underrated work that people should look into? I feel like even nowadays, a lot of people are starting to. I don't want to say forget or O'Neill, but he's not as much as
Hmm.
of a household name as I would like. Do you think there's other people in that same vein that we should remember and people should check out?
I don't know if we need to check out, but certainly there's a lot of giants upon whose shoulders we stand. Uh, Looking at beamed power, we always come back to Bill Brown's work, the original design of rectennas and microwave power. I knew about Brown pretty well. His main flaw, in my opinion, is that he was absolutely fixated on a frequency of 2.45 gigahertz. He just wouldn't even consider a different frequency or wavelength. I don't know if anybody still remembers Ed McCullough, who did a lot of work on uh, magma electrolysis. He really sort of showed that it was possible. Some very good work there. Of course, I love Freeman Dyson for his just absolutely wide-ranging imagination. He literally went all the way to the end of the universe. And well, some of his ideas may be a little bit beyond the beyond the edge of what we call technology today, but he was not afraid to think big thoughts.
You've been in this field for a long time. What has kept you going and kind of kept the space fire alive?
Oh, there's always something new and interesting that we learn. There's new missions that go out and say, "Oh my gosh, look at that! That's that's nothing we ever expected." And there's new technologies coming up, and we start saying, "Well, maybe we can use this technology. Maybe we can find a way to do interesting things with some of the technologies we're just inventing." So we're not really at the end of exploration; we're just at the very beginning. And if we keep it up, there will be some amazing things coming.
Yeah, I find I'm so often like bogged down in the details of technology and stuff. Like you said, it's very exciting. It's always changing. There's always a new puzzle to solve, which is like super fun. But sometimes just going outside and looking up at the moon and like realizing this is real. This isn't just a thing I'm always
Mm-hmm.
thinking about, you know? I feel like in some fields you never really like get to see what you're always
Mm-hmm.
looking at. Like you get to quantify it, but you can't really look at it. But with space, with the moon especially, you can look at it and it's right there. And it's so crazy that people will like turn their heads and be like, "No, I don't know why we should go to the moon. We should solve some other problems. We have so many problems here on Earth." But then I guess they need to go outside more. Is what I'm trying to say. It's like
Mm-hmm.
the space version of touch
It's
grass.
it's not an either or. We can
Hmm.
solve problems on Earth and problems in space. We don't have
For
to pick
sure.
just one or the other.
Where do you see humanity in 100 years from now?
I certainly would like to see humanity stopping having stupid wars. That's one thing I'd like to see. But humanity expanding out into the solar system. I think there's a lot out there, and we should be part of it. We should go out there.
Hmm. I agree. I think the more we look out, the more we realize how rare life is, and it
Hmm.
seems like a future civilization would view life and spreading life as like almost like a religious act. Just so
Hmm.
important, just because it's so rare and like what it took. I mean, the more we learn about even how the moon formed, the more we learn about like the rare Earth hypothesis and like
Hmm.
just the chances that we exist. These crazy walking, talking chemical reactions. It's yeah. So um, you've what you've spent a lot of time working in teams, collaborating in science in general. What qualities do you look for in people that make them stand out as someone you'd want to work with?
Uh, Somebody with interesting ideas, but with the background to be able to really delve into the ideas. What's useful in a team is to have people with different backgrounds. I don't really need somebody who knows the stuff that I know. I need people who know different things and can bring new approaches and new technical expertise to the problem. So, a small team with people, each of whom has a different specialty, is a real excellent thing to work with.
That makes sense. Do you ever find it hard to communicate complicated ideas to people that might not have that same background?
Oh, sure, all the time. I'm not sure if I have a good solution to that. It's I guess you have to work it out for yourself until you know all the implications, and then you can start teaching other people.
Yeah, I mean, I figured if you could solve that, that's like the ultimate communication problem is
Hmm.
like pervasive across time, and it's probably what would stop all wars. Like you said, if we could solve that problem, we'd be good. Um, What advice would you give to young people today?
My advice is do what fascinates you. Whatever it is that you think is really interesting, go work on that. And it might be, uh, it might be space exploration, it might be building and flying rockets, it might be art, it might be writing, it could be anything, but whatever it is, whatever you find fascinating is what you will be good at. And more important, it's what you will be happy at. So that's my advice.
Yeah, solid advice. Um, well, what are you working on nowadays? Is there something in particular that you'd like to talk about or let people know
Oh,
about?
I'm not sure if what I'm working on is yet interesting, but I've just finished a project looking at trying to use resources of Titan for exploration and bringing back a sample from Titan. And Titan is just absolutely fascinating in a scientific sense. So, uh, spending a lot of time on thinking about Titan, and of course, trying to come up with technology for exploration of Venus has been very, very, very interesting. So those are a couple of the projects that I've been working on.
All right, well, that's all the questions I
Okay.
had.
Well, send me a link when you put something together, and if you have more questions, you know my email. So
All right, I appreciate it.
okay.
Yeah, I really do appreciate it.